Hello, my name is Ben, and today I'm demonstrating my Python-based ping application for SRT-202, the high distinction task. This program implements a custom ping utility using ICMP echo requests built from scratch without relying on system ping commands. I'll run the program, show its output, and explain the key parts of the code to demonstrate how it meets the task requirements. First, I'll run the ping program to ping google.com. You can see it's pinging google.com, showing the IP address, packet size, round trip time in milliseconds, and TTL for each reply. If a ping fails, it will display ping request timed out. At the end, it summarizes packet sent, received, lost, and round trip time statistics. Now I'll test this with another host. Let's just go with yahoo.com. And the output is similar, confirming the program works for different hosts. Now let's dive into the code and I'll show you how it works. Just as a quick overview, the code is structured in several functions to handle ICMP packet creation, sending, receiving, and displaying results. It uses Python libraries like socket, struct, time, select, and OS to manage network operations and packet processing. The main function, execute_ping, orchestrates the process, while other functions handle specific tasks like checksum calculation and packet handling. I'll walk through the key components now. First, the compute_checksum function calculates the checksum for ICMP packets. It takes the packet data, processes it in 16-bit words, and computes ones complement sum. This ensures packet integrity as required by the ICMP protocol. The code uses bitwise operations to handle odd-length data and finalize the checksum. The build_ICMP_packet function constructs an ICMP echo request, and it packs a header with type 8 for echo request, a 0 code, a temporary 0 checksum, a packet ID based on the process ID, and a sequence number. I used a custom payload, custom ping, as dummy data. The checksum is calculated and then packed into the final header using struct.pack with network byte order for consistency's sake. Next, the dispatch_ping function sends a single ICMP packet to the target IP using a raw socket. It records the send time for RTT calculation. The capture_ping function waits for the reply using select to handle timeouts. It extracts the ICMP header from the received packet, starting at byte 20 to skip the IP header, and unpacks fields like type, checksum, ID, and sequence number. If the reply matches our packet ID and is an echo reply, it calculates the RTT and retrieves the TTL. And finally, the execute_ping function ties everything together. It resolves the host name to an IP, creates a raw ICMP socket, and sends 4 pings by default, 1 per second. For each ping, it calls dispatch_ping and capture_ping, displaying results like packet size, RTT, and TTL. If a ping times out, it prints ping request timed out, and it tracks packets sent and received for the final statistics. At the end of the program, it prints a summary showing packets sent, received, lost, and the loss percentage, and if replies were received, it shows the minimum, maximum, and average round-trip times in milliseconds. This meets with our task requirements to display key statistics clearly, mimicking the behavior of the standard ping utility. I kind of just tried to structure my output similar to the one you use in CMD and Windows. Next, the code handles errors like invalid host names, permission issues for raw sockets, and timeouts, ensuring robust operation. It meets all task requirements. It sends and receives ICMP packets, calculates RTT, displays statistics, and runs only on the client side, as obviously the server-side functionality is just built into the OS. I tested it on multiple hosts as shown and included screenshots, and this screencast obviously for submission, along with a 300-ish word reflection and summary on my learning about ICMP and network programming. But yeah, that's my ping application. In conclusion, it demonstrates strong networking concepts like raw sockets and ICMP, and fulfills the high distinction criteria for SIT 202. The code is functional and I think well documented, and I'll submit this code, the screenshots and my reflection and such to OnTrack. Thank you for watching, and I hope this showcases my understanding of network programming.